Hello guys, and welcome to this NumPy full course. In this video, we are going to talk about all the NumPy functions that are used in practice by data scientists, Python developers, data analysts, etc. So, what is NumPy? NumPy is a Python library used for working with arrays. It offers comprehensive mathematical functions, random number generators, linear algebra routines, Fourier transforms, etc. It is fast and versatile. It supports a wide range of hardware and computing platforms and plays well with distributed GPU and sparse array libraries. And also, it is an open source software. To start, we have first to import NumPy. So import NumPy as NP, and to create an array we call it, for example, a equals to np dot array. You open the parentheses and you open the square brackets. You define your array. For example, we say 1 2 3 and 4, and we execute that. Right, so we have an array of 4 elements. We display the shape within the shape a.shape. So we have a vector of 4 elements. We can also use the length of a. So here it says that we have 4 elements. We can also use the ndim word. So a.ndim, which gives us the dimension of our array, which is 1. Since we have a vector, we have 1 dimension. Okay. We can also use the dtype. Okay, so we write a.dtype. So we have integers. The elements of our array are integers. So this is about 1D array. We'll define another array, which is np dot array, which will be a 2D array. So to define 2D array, we open the square parentheses, space. We open square parentheses again. We define our array. So 1, 2, and 3, comma, and we define another 1D array. So in a 2D array, we have two 1D arrays. Okay, so we run that, and B will be an array of 2 rows and 3 columns. So if we write b dot ndim, it says that it is a 2D array. Okay, so b dot shape, we have 2 rows and 3 columns. We have the length of b, we have 2, since we have two 1D arrays to create a 2D array, and we have also the size. So b dot size is 6. So we have 6 elements in our array. If we write the dtype also, we will get integers as the first one. So this is about the first, or the 1D array. The 2D array, so we said that in a 2D array we have two 1D arrays, and now to create a 3D array we need to have 2D arrays in our 3D array. For example, we'll create a 3D array which contains 2D arrays. So write np dot array, you open the parentheses. So we said that we have to define a 2D array and a 2D array. To define 2D array, we open square brackets, we open again square brackets, we have 1, 2, and 3. We open square brackets, so 4, 5, and 6. So this is a 2D array. We create another 2D array, so we open square brackets, we open again, we have 7, 8, 9, and we have another 1D array, so 10, 11, and 12. So here we have 2D array separated with a comma by another 2D array, and we put all this together inside square brackets. We run that, so C will be a 3D array, so C.ndim is a 3D array, so C.shape we have 2 by 2 by 3, since it is a 3D array, so we have 3 dimensions. We have also the length of C is gonna be 2, since we have 2D arrays in to create our 3D array. We have also the size, so we write C dot size. It has 12 elements, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 elements. And also for the D type, so C dot D type, we have integers. Okay, so for example, we have created B, which is a 2D array. If we want to convert our array into a matrix, we can write, for example, mat equals to np dot matrix and write B. Okay, so if we print mat, it is a matrix. Okay, so type of B was numpy.nd array, and type of mat, it is a matrix. Okay, so if you want to convert your 2D array into a matrix, you use np.matrix. Okay, now if you want to create matrix of, for example, or a vector of zeros, we can write, for example, vec 1 equals to np dot zeros, and we give it, for example, we want 5 elements. Okay, so vec 1, we have an array of 5 elements, so a vector of 5 zeros. If we want to create a matrix of zeros, we write np dot zeros, and we double our parentheses, so we write 3 by 3, and we print that. So we have 3 by 3 matrix, so we have square matrix that contains zeros with zeros. Okay, same thing for matrix of ones, so we have vec 2 equals to np dot ones, so we have 7 ones. Okay, if you want to create matrix of ones, okay, so create matrix that is full of ones, so which means that it has only ones, we double the parentheses and we create a 4 by 5 or nothing. Okay, so we have 4 rows and 5 columns, all the elements are ones. Okay, now for example, if you want to create another vector, so we call it vec3, it is np dot, for example, arrange. So this function requires 3 elements, so we have, for example, the beginning, the end, and the value, for example, the incrementer. If we want to increment by 2 or by 3, we write 3 here. Okay, so the arrange function requires 3 elements. It starts from 1 to 20 and it will increment by 3. Okay, so 1, 4, 7, 10, 13, 16, and 19. 19 plus 3, it is 22, which is greater than 20, so it will not display it. We have also another function, we call that beans, since it is used for histograms. Mostly it is used for histograms in data visualizations. If we want to create, so our beans, we write np dot linspace. It requires also 3 elements. So we have the beginning from 1 to 20, sorry, and rather than, we write the incrementer here, like a range, we write the number of elements. So here we have written the incrementer is 3. Here we can write, for example, how much ranges that we will have in this linspace function. For example, if we want to have 10 elements, so it will give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, for example, here if I started from 1 to, let's say, 20, and I want to 20 values, so it will give me 20 values, 1, 2, 3 until 20. Okay, so here we define the number of elements that we want to have inside our array. Okay, and this is very useful when creating histograms in data visualizations. Now we can also create an identity matrix using 2 methods. So the first method is np.identity. For example, we want 4, so 4 by 4 matrix, and it is an identity matrix. Okay, so 1, 1, 1, 1. We can also create it using the I function, so np.i6 will have the same thing. Okay, so 1, 1, 1, 1, 1. It is a diagonal or identity matrix. Okay, we can also create a full matrix. We call it that f. It is equals to np.full. For example, we will have a 3 by 3 matrix, and all the elements will contain 5. Okay, so we'll have a 3 by 3, and all the elements are equals to 5. Okay, we can also create another matrix. We call it R using the random function. So we have np dot random dot random, sorry, and this matrix will use also the double parentheses, and for example it will be a 2 by 2 random. Okay, so R, so we'll have values between 0 and 1, and it will create for us matrix which is a square matrix by 2. Okay, and finally we can create an empty matrix, okay, using the empty function. So np equals to np dot empty. Okay, we use also the double parentheses, and for example we create a 4 by 3. So if we display that, sorry, we'll have the empty matrix. Okay, now for example, if we want to create another array, we call it ar np dot array, and we give it random values. For example, 3, 7, 6, 8, 9, 1, 2, and 3. Okay, run that. ar. First, we can create a copy of our array. So ar copy. So it is equals to ar dot copy. So if we want to run that, we'll get our array. We can also sort our array using the sort function. So write ar dot sort. So we'll have our array sorted. For example, we can use the array that we have created in here, so which is the B, for example, B array, we copy that and we use it in here. So we have B equals to an array with 2 rows and 3 columns, and we have our AR, which is now sorted 1 2 3 until 9. First, we can use the indexing, which means that we can access our elements one by one. For example, the element 4 is 6, so 0 1 2 3 4. Okay, since it is a 1D array. If it is a 2D array like B, so we use B. For example, we want to access for example the element that is in here. So we have here row number 0, number 1, so we have 1 and 0 1 2, so we have 1 2. We write, for example, 1 2 will give us 3. Okay, and for example, if we want to access all the columns, and which means we will access only, for example, the first line, so we write P first line, which is 0, and all the columns. It will give us 1 2 3. And same thing if we want, for example, to access the third column, for example, so we write here and we have 2. Okay, I'm sorry. So it will be like, for example, B, we said here it is all the rows, so here B, and we have from 0 to 1. Run that file and valid syntax. So we said that we want to access, for example, the first line, first column, so B10 is here, so B10 is in here. And if you want to access the third, so we have B all 0, all 2. So we have 3 3. So we have here the third column. Okay. So I forgot the 2 dots. So this is for indexing and slicing. And for example, if we want to access all the values that are in B and they are, for example, greater than 1. Okay, so we write B and all the values in B which is greater than 1. It will give us new array. So we have 2 3 2 3, right? 2 3 and 2 3. So this is called Boolean indexing. So it is called Boolean indexing, right? We can also continue working with B. So we have B, it is equal to 1 2 3 1 2 3. If we want, for example, to transpose our array, we write B dot capital letter T, and we will have a new shape. So B dot shape, it is a 2 by 3, but this is B transpose, right? And we run that. So the shape of B is this 2 by 3, and the B trans, which is going to be 3 by 2, right? Oops. A 3 by 2. Okay, so this is a transpose of our matrix B. Now, if we want to flatten the array, which means that if we want to convert our array into a 1D array, we can use the rival function. So we write B, for example, dot rival. Okay, it will create for us this matrix. Okay, so 1 2 3 1 2 3. We can also use it for C. So we have here the C that we have created earlier, which is in here. If you remember, it is a 3D array. So we can use C dot rival and we have said that it has 12 elements, so we have from 1 to 12. Okay, so rival function is used to convert a 2D, a 3D array into 1D array. Okay, we can also, for example, so here we call it, for example, C rival. Okay, it has 12 elements, so we can use the reshape function to change the shape of our array. So reshape, and for example, since it has 12 elements, we can turn it into 4 rows and 3 columns. Okay, cannot size 12 into 3, sorry, so set 3. Okay, so we call it here, we call it D. So D is 4 by 3 array, so it is a 2D array and it has 4 rows and 3 columns. We can, for example, insert elements into our array, so we write D dot insert. Okay, and for example, the insert function works as the following. So we enter our array and the element, for example, the element which is, for example, 2, and we add, for example, here if we want one number, for example 1. Okay, object has no attribute insert, so it is np, sorry. So we have 1 2 1, so we have said in position 1 we add 1, in position 2 we add 1. For example, if we put here 10, you can see in here it will create, or it will use the variable function, and it will directly append or insert our value into the array. Now this array, we cannot convert it or we cannot reshape it since it has 13 elements, so we cannot add or create a matrix, for example, that has for example 5 rows and 3.5 columns. Okay, so what we are going to do is, for example, we can add 3 elements, so we add 10 20 and 30. Okay, so here we will have this new array, so we call it E, and we want to reshape E since it has 15 elements, so we can call it reshape, and we write 5 by 3 EF. Okay, now if we print F, so we have added these elements and we have created a new matrix or new array which has 5 rows and 3 columns. We can also use the delete function, so np.delete, and we enter the array and write, for example, 1. So it will delete for us 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So we had 15 elements and it has removed for us the first element, so we start from 0 to 1. So we have here 0 1, it has removed 2. Okay, now this is our new array, so we call it G. So G, run that, and if we write that again, G dot delete, so we enter sorry, it is np dot delete, and we enter the array and the position. So if we write 1 again, so we will get this matrix, it has removed 10. Okay, now for example, we can create other arrays. We call them r1 equals to np dot array. Okay, so give it value 1 2 and 3, and you create another array, so r2 equals to np dot array, so we that 4, 5, and 6. Okay, so we have the two arrays. Oops, sorry. Okay, so we can combine arrays using three functions. The first one, it is concatenate. So we use np dot concatenate. Okay, and we call that ar1 and ar2. Okay, put that between parentheses r2, and for example we define our axis. If we put axis equals to 0, we will get the one column. Okay, so it will be like that. And if we choose axis equal, okay, so we create another line code. So okay, if we choose axis equals to 1, it will say that axis 1 is out of bounds for array of dimension 1. Okay, since we do have only one dimension, so we can only use the axis 0. Okay, now if we want to create r4 equals to, let's say, np dot array, for example, we call that so 1, 2, and it will be 3, 4. Okay, so this is array number 4. Okay, around that, and we create so r5, and we put here, for example, 5, 6, 7, and 8. Okay, so here if we use np.concatenate r4 and r5, so it will give us this array. Okay, so we have the r4 is 1, 2, 3, 4, and it will add directly the 5, 6, 7, 8 into our array. Okay, new array. So r5, it is 5, 6, 7, 8. So we will have 2 rows and 4 columns. Now if we use axis equals to 0, so it will give us 4 rows and 2 columns. Okay, if we use axis equals to 0. We can also have two methods. We have vstack and hstack. So v stands for vertical and h stands for horizontal. Now if we use np.vstack, okay, and we call our function so r4 and r5, so we'll have vertical concatenation, so as using the concatenate function with axis equals to 0. Now if we use np.hstack, so we have r4 and r5, so we'll get as axis equals to 1. Okay, so we add by vertically. Okay, so vertically, so we append this into this one vertically, and here horizontally. So hstack, we add the columns, and vstack, we add the rows. Okay, so it depends, it's up to you to choose which one to use. For example, concatenate with axis or the vstack and hstack. V stands for vertical and H stands for horizontal. For example, we call this the R6. Okay, we run that. So R6. We can also, so we said that we can combine arrays. Now we can also split arrays. Okay, so if you write np dot h split, h split, and we enter, for example, our array, so R6 into two arrays. Okay, so we'll have 1 2 3 4 and 5 6 7 8. So 1 2 3 4 and 5 6 7 8. Okay, since we have chosen to do that horizontally, okay, so it will create this array, so it will separate it from here, 1 2 3 4 and 5 6 7 8. We'll get two arrays. Now if we use vsplit R6 and we do it by 2, we will get 1 2 5 6, so 1 2 5 6 and 3 4 7 8. So it will split the array vertically, so we'll get two arrays. Okay, now if we want to use, for example, the aggregate functions, we can by using NumPy. So we call that, so the R, let's say 6 dot variable, for example. Okay, so name R6 is not defined. So A is the matrix. Now, for example, we can find the mean of our function, so of our array, sorry, A dot mean. Okay, so it is 1. A dot max, so A dot sum, so np dot come sum of A. We can find also np dot std of A, standard deviation. We can find the median, np dot median of A. We can also find the mean, A dot mean. So this is are the aggregate functions with NumPy. And also we can use the arithmetic operations. So for example, if we have like previously we have R4 and R5. Okay, so we can use np dot add, for example, R4 and R5, give us an array. So np dot multiply R4 and R5. Okay, so we have the multiplication, subtraction, division. So np dot subtract. Okay, subtract. We have R4 and R5. So what else do we have? The division. So np dot divide. So np dot divide. So R4 and R5. Okay, so here we have the division, and we can also use, for example, the exponential, np dot exponential, for example, the R4. Okay, so this is about the arithmetic operations. So this is all for the NumPy tutorial. I hope that you have learned new things. Thanks for watching, and see you in the next tutorial.